Universal Time.
I am in radio contact.
Today in the lab, we are building a Buster Beagle Mark I injection molding machine. So I started collecting parts with various AliExpress retailers. That's how you build this thing the cheapest. Some of the parts in the box we won't use, and others we will, but I'll try to keep a running tab of how much building one of these machines costs. It's probably somewhere in the $200 to $250 range, but we'll find out together. So the Mark I Buster Beagle is kind of a open source do-it-yourself kit where you find the parts yourself and build it yourself. There is a couple of components you get by the gentleman that designed this at busterbeagle3d.com, I believe is the website address. So the major components are two drill presses, and these are kind of cheap drill presses, as we'll see. If you look around, you can find them in the $15 to $25 range, and we need two of them. And with the box open, we can see the parts that are included in the drill press kit. We get a 25mm pipe, which is to be used as the back spine of the press. We have the pull-down handle. One of these will have to be modified so it's slightly longer. We have the base stand and the main functioning part of the drill press itself. Drill cyan. Alright, let's get started on the machine. So we will get started by working on the lower mount where the heat chamber will go. They've included a Allen wrench Phillips combo. Nice little thing to have. So we'll just take this apart and save what we take off of it in case we need something later. And well, that's best to use that little wrench as just a just an Allen wrench. So take that guy off because we don't need him. Take these off. Of course, the screwdriver you pick is never the right size. I don't know if that's open or not, but give it a bell. All right. Okay. remove these C-clips here, because really what we're after for the lower bracket is just this portion. So save the rest of the pieces you get off of this for now, just in case you need them later or need them on a different project. It's going to be strong enough. Yeah, no grip strength on those. Try our wire cutters. Come on. Jackpot. Alright. So this is the bracket which will hold the heat chamber. Coming in at $135, this 3-piece kit is probably the most expensive part about building one of these machines. Included, you get the heat chamber with the nozzle, the top screw bushing, and the plunger that goes inside of the injection chamber. The 3/8 by 16 by 6-inch long bolt is not included and available for an additional $2, plus I believe I paid around $9 for shipping and handling. Alright, so now that we have our bottom bracket ready to receive the parts, remove our retaining bolt. Perfect fit. Our retaining bolt goes in like that. And then that's just to give you a little bit of more pull-out strength, I believe it was. And use our Allen wrench to snug up the bracket. Where I'm deviating from the original plans a little bit is I've gone with these brass heat rings. So these are the same specifications as the original ones that the gentleman at Buster Beagle 3D sells, and I believe he sells his for $12 each. I picked these up for, I think it was like $10.50 to $11 each, but I preferred this style because they're brass and the connections come out in this braided cable here, and then also included in the package are these little sandstone insulating terminals for the wiring to go through, so I think that'll make a little bit of a neater installation, which is why I went with this method. And quite literally, it looks like they were built the day that I ordered them. Alright, so now, since I need to mount the temperature probe, we will talk about this kit. So this is a Rex C100 temperature controller, and I bought this as a kit. I believe it was around $10. It might be cheaper, it might be more expensive, your mileage may vary. So I've seen these range anywhere from like $5.50 for just the Rex C100 to say $12.50, $15 for the whole kit here. So we get the C100 temperature controller, we get the thermocouple probe, we have a heat sink that attaches to a solid state relay. So the temperature controller will command the solid state relay here to turn on and off and adjust the temperature of the heat chamber accordingly. And here are the specifications of our thermal probe for the people playing at home. And apparently the tip of these is fairly fragile, so we don't want to over tighten it when putting it into the heat chamber. So I think I'm just going to give it a little bit past finger tight and call it good. So this is how our assembly came out. We have the two heating clamps. So I'll have to figure out where I want to put our block. And on this side I have the temperature probe. So I'm doing the Buster Beagle a little bit different. I'm going to make it to where it is, I can quick disconnect the injection chamber from the control box, and to do that I'm going to use a this is a C13 to C14 cable. So we have male on one end and female on the other. So I will give the male to the receiving end, so we eliminate the chance of someone poking their fingers in here if it's disconnected to get an electrical shock. So this will be the power supply side, and this will be the taking the power side. But anyways, so we will use part of this cord, and I'm going to take the sandstone terminal block and mount it about here to insulate the heat from the power cable. And I drill into the bag to try to catch the chips from keeping them from going all over the lab. Also, it's a good idea to try to keep your finger out of the way. Yeah. I picked me up a box of these little crimp-on terminals, and I've never used them before, but I'll see how they go. I believe I got, what was it? The assortment in the crimper, I think, came to around $18, but I'm not exactly positive, and this is entirely an optional thing, so I just wanted to make mine look pretty. You don't have to do this. So, turns out our C14 to C13 cable was European standard, so it is brown is our hot wire. So we will go to a black terminal for brown. And then blue is our neutral, so blue is going to white. And this is an 18 gauge power cable, by the way. So I've never used one of these before. Kind of don't want to crimp all the way home. So I'm just doing like maybe 2 notches. So enough to secure. Good. And while you weren't looking, I finished wiring up our power input lead. So there's C14 coming to our sandstone block, and now I'm wiring the heater bands into it. So I'm going to have to go with red and blue on this side because that's pretty much the colors I have that look like they want to fit this gauge wire. So it looks like it's 18 gauge wire coming off of the bands, but we're going to have to put them in parallel because I live in America, and you can wire these in series for 240 volts, but I'm wiring the bands in parallel for 120 volts. For all I know, this won't even fit, but we'll give it a try. Oh yeah, that'll work. Yes, that'll work out good. Okay. What I did with that tool. Okay. Alright. So what I do here, black on the bottom, so I guess I'll do red for black in this case, and don't judge me, but like I said, these are the colors I have on hand and available at the moment. So I think what I'm going to do is give these a little bit of a trim. Okay, and same thing, I'm not going to go all the way down on the tool. That actually comes out pretty good, I'm surprised. And there you have it. we can... get our terminal in there. Alright, and our connections are completed. And it turns out I forgot I bought these. These are, I believe they're M6 by 100 millimeter long screws, and I have the matching M6 nuts, and that is to replace the screw that goes in here, because what we are going to add is some knobs so we can lift up and move the heating chamber off of the mold. So these are like joystick knobs that I found on AliExpress. I think they were like $2.50, $3 each, and I got 2 of them. The screws I think were in the $2 range, and the bag of nuts was in the $2 range. And today is tomorrow. So today we're going to get started on our electrical housing. Since I don't own a 3D printer, I use the company that makes my printed circuit boards to make my 3D printing needs. So they, JLC PCB also has JLC 3DP for their 3D printing division. So this is the contents of the order from JLC 3DP. I believe it was about $25 to print the entire order, including shipping, but I'll check that and update the screen. But this is a resin print, which I believe they call their new just JLC black resin. One thing I've noticed is it's a little bit thin, so the rear panel here is a little bit on the flexible side. But I prefer to use resin prints because you can't really tell it's been 3D printed. But actually very nice black color. And you can barely see the lines at all. Alright, so here's the included wiring diagram that's in the zip file that also contains the 3D printed stuff that you can get from BusterBeagle3D.com. I have a black and white printer, but that's fine. I'm probably going to change some of the colors around anyways because they'll make more sense to me. But you can use the colors that are in the diagram, or you can mix them up yourself. Just as long as you know what does what, and I do recommend that for the AC connections, you stick by the colors that are for the American color code, where black is hot, white is neutral, and green is ground. I also picked up from AliExpress. This is a assorted wiring bundle of 16 gauge wire, and I will measure that because sometimes you'll buy 16 gauge wire and it is, or actually any copper wire for that fact, it'll be, say, 16 gauge for the outer jacket, but then 18 gauge copper inside, so you have to be careful and watch for that. Alright, we are done making most of our wiring harness. I decided on red and blue for the solid state relay because black is in use for the AC hot. Made my pigtail to go to the heater, and I'm employing these quick disconnect connectors here so that I can install stuff into the housing easily. So what I've done here is there's like a male and a female end, so I've made sure that this is the correct ends for ground and that I can't connect neutral into ground, which is over there. So that'll be good. I've also modified the cable that was coming off of the thermocouple so that I have an 1/8 inch stereo jack. The ground of this cable is actually steel, so I can't solder to it, but inside here I've crimped it to the sleeve connection, and I'll do the same thing on the heater side when I get to that point, just with the male end of the 1/8 inch stereo jack. The solid state relay also came with a heat sink, and it didn't come with these screws, but these screws are M4, and if you look ever so slightly, you'll notice that your heat sink might be a little bit out of whack from where it was bent at some point in time, but you're probably going to want to bend that as straight as possible, then put some heat sink compound in between the two surfaces and try to get it the best you can. So I'm just using Arctic alumina by our friends at Arctic Silver. I'm not even sure if they still make this, but I bought this tube probably 10 years ago now, and yeah, it's kept me going for my heat sink compound needs. Mhm. I'm gonna call that good, since this is like a supplemental heat sink, and sometimes you can get away without even running this. Okay, since this one's polarized, you want to check on the side, figure out which one's the positive and which one's the minus. So in this case we're on 4 and 5 for a solid state relay. Minus is on 4, positive is on 5. I've also wired the AC input and the power switch, so those are done as follows. Now the switch actually came off of the housing, and I decided that I wanted this way to be power and this way to be off. So pay attention to that. And then also for the ground, I have that going to go to my pigtail on this end, and then I've left this end unterminated for now until I can figure out where I want to mount it on the frame. So that'll determine what size spade lug I need. Nice fit. Alright, our electrical housing's now complete. So we have the AC input on the back. These are two number 3 plastic tapping screws. Power switch. On the bottom here we have the cables, the heater, and the thermocouple. Ground to be determined. And this is what it looks like on the front. So one thing to note is the wiring that is in the Buster Beagle diagram is awfully tight. So I'd recommend adding an inch to most of the connections, except for like the ones that are on the back of the plug that wire the incoming AC to the power switch. Those are fine lengthwise, but everything else you probably want to add an inch to, because it's awfully tight to start screwing everything together. Even after you put it in. They actually leave this little slot on the enclosure to help you wire up the solid state relay. And then there's also a little trap door underneath that'll help you with routing the wiring later. Alright, now we can move on to modifying the top part of our unit. So, start by removing all this stuff. That part has to stay. And want to remove the C-clip off of this. There we go. Alright, nightfall has bestowed us. One of the things I've noticed about the top portion is we're not drilled out on this hole, so I'll have to drill that out a bit later so we can mount the power control box. Now that we have the shaft removed, I found an M10, and I believe it was a 150 millimeter long bolt, so that'll go in the top here. And I also found nylon insert nuts to retain the bolt. Drill sand, and in a unorthodox use of tools, I'm just using a straight screwdriver as a hole reamer to clear out this hole so that we can use it for mounting. Now we can insert the Buster Beagle bushing. We want the lip on the bottom side, and we can tighten it down. And one of the things that I've noticed is that our nut on the M10 bolt doesn't clear this internal screw post, so I'll have to cut that and remove it. So as it turns out, the mounting hole is in the wrong position for the electronics enclosure that I printed out. So I've done a little scribe hole here so I can drill that out and move that over a little bit. So if you look in the files for the Buster Beagle 3D Mark I, they show you a couple of different castings where it seems like this hole should be here, but this must be like a third version of the casting is all I can think of. And with that, our control box mounting is complete. Note there is a Allen wrench screw hole down in here that you'll need to tighten as well. And forgot one last thing, we need to modify the second handle so that we have this extension piece. So I have to cut here and enlarge this hole a little bit. So this is to replace this normal sized part we get and give us an extra little bit of pull down range. And that is why we wear safety glasses. With our sub-assemblies complete, we can now start putting the injection molding machine together. Start with the base, we will put the 25mm shaft onto the base and get that level inside here before we tighten it down. Okay. So they include a couple, well, one each of these rings per kit, so I'm going to put one down first. And I can always take this off later. Just tighten snug. Okay, so now we want to install our heater and injection molding chamber. Okay. Alright, and here is the assembled unit. So I've attached the handle on the side and added our modified piece here. Now note, when you press this down, if you press it down too much, this pivot point here can flip onto the other side and it'll kind of do it in a violent flat fashion. So keep an eye you're not pushing too far down on the handle. And then this is the control box, how it mounted up on the side, and then this is our connections that have been made. So the quick disconnects for the thermocouple and the heater bands. So let's turn it on and see how we did. Came on first time. So if I understand this right, the red is the temperature in Celsius that we are at currently, and the green is where we have the controller set to. Oh yeah, our bands are getting hot. So yeah, looks like we have a successfully functioning Buster Beagle Mark I. Well, as always, thank you for your time and try to enjoy yourselves the rest of the day.